Hello everyone. In this video, I'm going to be going over some of the basics for geometry. I'm going to call this video Geometry 101. If you notice, this is all just kind of handwritten here, so I'm going off the cuff a little bit. And just like I mentioned, trying to apply some of the basic vocabulary terms, notations, and principles. So we'll go through diagram by diagram, and I'm going to try to keep this on the quicker side. We're going to start in the top left. So if you notice here, we have two triangles. I'm looking right here. We have triangle ABC, D, and DEF. Now, some of the notation here. If you notice first, look at the sides of the triangles. You see these little tick marks or slashes. These are going to note the corresponding sides that are congruent to one another. First of all, I should have wrote that as well. So there's no surprise here that these triangles look very similar. The notation, the first one that we're going to reference, this little equal sign with the little squiggly above it, refers to congruency. Now, congruent is a way of saying basically, quote unquote, that these triangles are equal to one another, but obviously that wouldn't make much sense. You wouldn't say like this is equal to that. It's like saying they're kind of exact replicas, right? Every part of them is the same. The sides are going to be the same measure. The angles are going to be the same. It might just have different names, and we're going to talk about that. Now with the letters, it could be anything here. I just wrote A, B, C, and D, E, F. It is important that they correspond. Notice that angle A in the bottom right-hand corner, let me grab my laser pointer, angle A corresponds to angle D. Now when I wrote them out, A and D correspond. B corresponds to E, and C corresponds to F. So there's this like correspondence that goes back and forth when you talk about congruency. Now getting back to the side lengths, the tick marks. So we have one tick mark on the left. Now you might be saying like, what's the point of this? Isn't this common sense? Think about if the triangles weren't oriented like this. In other words, what if like one was kind of spun around? Sometimes they're going to be looking a lot differently than just side by side and at the exact same orientation. It is kind of common sense when it's written like or drawn like this, but when they're oriented much differently, and you'll see these, you know, in a parallelogram proof, you'll see these in just a triangle proof where they're kind of upside down, flipped over in different spots. It's important to, and it's helpful, I should say, adding tick marks and stuff helps you see what's congruent to what. With the angles, we have the little kind of accounting system, I guess if you want to call it that as well. When I put the little loop here, it's saying, hey, this and this are the same angle. In other words, if this is 50 degrees, this is 50 degrees. See, we have the kind of double slash up here, the double slash up here. When I look at this diagram, I know that angle B and angle E have the same measure. Once again, if this is 70 degrees, this is 70 degrees. And then we have our triple down here. So I guess the basic rating here is just the amount of either tick marks or I don't know what we want to call those angle marks. Basically just a counting system 1, 2, 3 to identify what is congruent, looking from left to right in the triangles. On the right-hand side, the top right, we have triangle GHI and triangle JKL. Now these, you'll notice, are not the same triangle. So what is this symbol? What's going on here? So it's almost like we just see the top part. I drew that a little funky, but we just see the top part. We just see that squiggle. This is known as similarity. These triangles are similar to one another. This is something you might have seen in 6th grade, maybe see it, you talk about a little bit with proportions and stuff like that. If you had a good teacher, I don't know, probably not. So what does this refer to? Similar triangles are obviously not, we can't say like they're quote unquote equal, they're not congruent, they're not the same measure, but there is a relationship there. What this is saying is if this side is, let's say 3, and this is 12, and this is 5, and this is 20. So you see what I'm getting at here? What's the relationship? And then let's say this is, I don't know, 6. What would side KL be on the triangle on the right? That would be 24. So the relationship here is that triangle JKL is 4 times the size of GHI. So every side is going to be 4 times its length. Now, it's not going to be this straightforward, and there's different theorems, side splitter theorem and things like that get a little tricky. But once again, this is the basic fundamental idea with similar triangles. The angles are the same in similar triangles. So all the angles are actually still congruent. It's the sides that either just kind of blow up or shrink down. And literally what I did is a good way of visualizing what similar triangles are like. I literally copied and pasted it. Let's see if do I still have it. Yeah. So I copied and pasted it, and I just kind of went like this with my fingers. So notice when I do this, yeah, I'm making the triangle smaller or making it larger, but those angles are always going to stay the exact same measure. So that's important. The angles here are going to be congruent. Okay, so far we've talked about congruency, the symbol for congruent, the different little markings you'll see in diagrams, and then we talked about similarity. In the bottom left, this is a popular diagram. This is like classic math, 8th grade math lesson, which you guys obviously kind of fall in the cracks with. You don't really ever cover 8th grade math. You took Algebra 1, which is really like a 9th grade math class, but you kind of skipped over this easy topic. Not that it's anything bad or something like that, but this will just kind of give you a good idea for next year, some vocabulary terms. So we have a parallel diagram, and some of you that are in after school programs or SHSAT or stuff like that, or just any outside classes or tutors, maybe you've seen it there before. This is a classic geometry diagram. The first, we'll add another notation to our list. You see these two lines. First of all, something might be going on. You're like, hey, these look like train tracks. And obviously we know the word here, the parallel. Hey, these look like they're parallel. But this is the actual notation that tells us that they're parallel. I believe these are called feathers. I used to just always call them arrows. But they have these little feathers. It's a way of saying, hey, dude, these are parallel to each other. You don't have to like sit and measure it or calculate slope. It's a way of saying, hey, these two lines are parallel. Now what they're cut by, so let's add a little note here. Now what they're cut by is another line. That's called a transversal. That's a line that's kind of like slicing through them. And I labeled 8 different angles. Obviously 2 lines are going to make an angle together, right? So I have angle 1, 2, 3, 4, angle 5, 6, 7, 8. So there's a lot of different angle relationships that go on here, and we can actually calculate things even though there's no numbers involved. The numbers here are just like naming the angles. That doesn't mean like 1 degree or something like that. But there are some relationships, and that can help us find things if things were actually looking for a value or did give us some information. The first one that we'll talk about, I'm literally going off the head here, so probably going to make some mistakes along the way. Let's start with, what do we want to do first? Let's go with vertical angles. So there's vertical angle relationships in this diagram. Vertical angles. Vertical angles are angles that are across from one another. So an example of vertical angles would be angle 1. The angle symbol is like a little, kind of what you would like think it would be. Almost like a triangle, but missing that third side. It's a way of saying, hey, angle 1 without writing out angle. Angle 1 and angle 4 are example of vertical angles. So obviously 2 and 3 would also fit that mold. And in the bottom, 5 and 8, 6 and 7. I'm just going to write the 1 pair. So angle 1 and 4 are vertical angles. Now, I've sometimes heard these called bow tie angles before. I never really got this analogy. I guess it kind of looks like a bow tie. They're literally across from each other. I don't know, but I've heard that before. So what's special about vertical angles is that vertical angles are congruent to one another. So, not that we ever see a problem this easy, but maybe something we could use. If I know angle 1 is 70 degrees, I know angle 4 is also 70 degrees. So vertical angles are always going to be congruent to one another. Now let's run with that 70. Let's keep that 70 kind of in play here. Supplementary angles. Supplementary, probably spelling it wrong. It looks okay. Supplementary angles. An example of supplementary angles would be angle 1 and angle 2. So what does supplementary mean? It's a good SHSAT question, I believe. Supplementary means they have a sum that add up to 180. Supplementary means they have a sum of 180. Basically, they form what's known as a linear pair. That's another way of saying that. They're forming a straight line. If you weren't aware of this, think about a right angle has 90 degrees. A straight line is 180 degrees. So if you look at angle 1 and angle 2, how can I erase my highlighting? If you look at angle 1 and angle 2, they're forming a straight line together. So they're going to add up to 180 degrees. So if I know angle 1 was 70, which I just made up, which also doesn't make sense because that looks like it's greater than 90. So let's pretend that didn't happen. So let's say angle 2 was the one that's 70. It just wouldn't make sense to say that's 70 degrees. It looks like it's obtuse. So let's say angle 2 is 70. What would be angle 1? Angle 1 would be 110. Okay. Supplementary angles form a linear pair. So what's another example of supplementary angles that you see there? There's a lot, believe it or not. Not just going down the line. Obviously, you could say 3, 4, 5, 6, 7, 8. Where are there other supplementary angles? Tilt your head either to the left or to the right. If you tilt your head, I don't think I can do that with my iPad screen, but if you tilt your head, you might see this. Angle 7 and angle 5. They form a linear pair. Do you see it? Together, they're making up kind of the transversal as like their straight line, right? So that line has 180 degrees. Angle 5 plus angle 7 should add up to 180. Okay. Hopefully we're doing good so far. Let's throw in, we have corresponding angles. You know what, let me just write a bunch of words down and we can pretend that we did something. Now we could just kind of roll through this. Alternate interior, and alternate exterior, I guess, too. I'm curious how many of you are familiar with this in this diagram. Maybe supplementary is kind of common for a lot of you in prep classes, but I'm curious a lot of these other words, how familiar we are with this. I might kind of ask a poll question just to gauge where we're at. All right, so let's run through this. Corresponding angles. Corresponding angles, the best way of thinking about it is separating the top part and the bottom part. And it's kind of like matching them up. Like, hey, who's the top left of, in the red section? Let's describe it like this. In the red section, who's in the bottom left spot? That's angle 3. In the blue section, who's in that same position? Angle 7. So you have those kind of like match up, they correspond to one another. And obviously 1 and 5, 2 and 6, 4 and 8. So what's special about corresponding angles? You can kind of almost visually see this one. They're going to be congruent to one another. Okay? It has a look to it where you could pretty clearly see that's going to be the case. And once again, there's a bunch here. I'm just writing down one example. Alternate interior. Interior angles, if you're curious, like why are we talking about interior versus exterior, like inside versus outside? Think about the parallel lines kind of forming like a house here. So everything inside the parallel lines is interior, and everything outside is exterior. Can I write with the highlighter? Not very well. So these are exterior. Some people have trouble kind of seeing this, the whole idea of exterior versus interior. So think about the parallel lines as being like a little tunnel or something like that. So that's the interior portion of this. Exterior is outside the parallel lines. So alternate interior angles. This is the tough one. That would be angle 3. I'll give you the example, and then we'll talk about it. You have one of 3 options here, right? You know it's got to be another interior. So is it 4, 5, or 6? Believe it or not, it's going to be 6. So how do we get rid of that slash? Just doing everything. Okay. Angle 3 and angle 6 are alternate interior angles. So think about this. They're interior, they're inside, what we talked about, the blue. They're alternating, meaning they're on opposite sides of the transversal. That's what the alternating means here. Now, alternate interior angles are congruent, meaning, hey, if this was 60 degrees, this would be 60 degrees, right? Another example of alternate interior, there's only one more, 4 and 5. They're on opposite sides of the transversal. Okay, opposite sides of the transversal. Now, alternate exterior is going to be the exact same thing. They're going to be congruent as well. So angle 1 and angle 8. So they're not adjacent to one another, and they're on the other side of the transversal. You can't just say like angle 1 and angle 2. Those are supplementary. Obviously, those are not the same. But angle 1 and angle 8, and angle 2 and angle 7. And there's a few more, but I'm going to kind of pause it there. These are some of the main ones. Like I said, I'm probably missing something, but hopefully this wasn't too crazy with our angle diagram. Alternate interior, alternate exterior, corresponding, all of these, you're like, are we just going to see this diagram for a month or something? No. It can come up in the middle of a proof where you can prove that two triangles are congruent, and you can use kind of one of these as your justification or your reasoning. So knowing the vocab is going to be very important. Same thing up here. The notation and things like that seems simple, but it's important to know it in the middle of a problem. Geometry is not as much about solving for things. That's obviously literally like algebra 101 stuff. It's more so about understanding the different theorems and then using them. The actual problems that you do have to solve in geometry are actually pretty easy, but it's the knowledge of knowing all these different rules. And we didn't even cover, page 1 of the textbook in this video. It's just knowing all those different rules and how to apply them. But that's everything that I wanted to cover. I'm still deciding. I wanted to do something Monday, Tuesday, and Wednesday this week. So this is for Monday. For Tuesday and Wednesday, software update. For Tuesday and Wednesday, I'm still deciding what to kind of play around with. It's tough to decide like what to give a preview in 3 days of an entire year. So I'm playing around with that. And then Thursday and Friday, I'm thinking about doing something obviously kind of on the low-key fun side. I'll put up some type of poll, and we can decide what we can do to have some fun to celebrate the end of the year. But that's everything in our very first geometry lesson, my very first geometry lesson as well, teaching it. All right, thank you guys for participating in this video. If you are watching it, probably 3 people in the 3 classes that are watching this, thank you. But no, you guys have all been doing your work pretty well, even though the grades are done. Still a bunch of you keeping up with that stuff, and I appreciate that. But thank you for watching. Have a great day, and take care.